A lot of you have mentioned to me again that chemistry is one of the subjects that you usually find quite difficult, so you want to see a video on that. So here it is. When we usually think about the subjects out there, a lot of people think that the top level maths is usually one of the hardest subjects that you can do in year 12, but also alongside that is usually physics or chemistry. And this makes sense, right? Because a lot of the things that you learn in these topics, you need to know how to have those sort of inference skills to take it to the next level. And often you're going to see curveball questions in your tests and exams as well, and you have to be prepared for that. Okay, so hey guys, I'm Archer. I'm a second year medical student, and on this channel we learn how to learn so we can spend our time on the things and people that matter most to us. I'm going to be breaking down everything that you need to know about how can you approach chemistry so that you can make sure that you're not missing out on any little bits. And also so that you can be best prepared for the exam at the end of the year. The little details for some of these techniques are mentioned in some of my other videos, so you might want to go check those out as well. So we're going to start off with inquiry-based learning to build that very deep and conceptual understanding of the concepts within chemistry. Then we're going to talk about chunking, and in that as well, we might mention a little bit about the use of flashcards maybe. And then we'll look at the journey to reaching mastery with chemistry so that you can be best prepared for that exam. All right, let's get straight into it. So as I've mentioned many times before, there is this idea of inquiry-based learning through questions. This is a very broad model of a way to approach learning in general. And if you think about it, when you ask questions, you're usually going to ask questions that you're curious about. So in a way, this is going to be more fun because you're using your curiosity to try and figure out a puzzle, try and figure out a problem. The research is also pretty strong on this as being a quite effective way of approaching your study. With using your curiosity, you're always going to be targeting your biggest weakness at that point. You're not going to ask a question about something you know already a lot about. For example, you're not going to ask, what is an isotope? If you already know what isotopes are and you're in year 12 chemistry, dealing with organic chemistry and acid bases, equilibrium, all that sort of stuff. So the usefulness of this compared to just passively reading through a textbook or listening to your teacher in class or watching a lecture is that you're always targeting that weakness first. It means that you're always being super focused and always making the biggest improvements in terms of your learning at any certain point. And if you can approach that in that way, it means that sometimes these bigger questions that you have are going to solve 5 other questions that you might have down the line that might be more specific and dealing with smaller details. When you know a lot about the bigger picture, that can sometimes clear up a lot of the things that are very niche and really small details. So how do we start doing this? Well, when you're learning content for the first time, whether it be in class and preferably in a textbook when you can do this more at your own sort of pace, you want to ask this first question. Why is this particular concept important? And then from there, you want to think about how does this relate to X or Y or what other concept that you might have learned just before or something else that you think might be related. So for example, I might be learning about equilibrium. I might ask myself, what makes equilibrium important? Why am I learning this? Yes, it's to, eventually get a good grade in my exam, but why is this part of all of the chemistry that I'm learning? How does it relate to everything? And that's the second question, right? How does it relate to X? So you might be learning about pH buffers. How do pH buffers relate to equilibrium? And you'll realize that they are very intrinsically interrelated and that it doesn't make sense for them not to be related. So we can zoom in with this and learn about specific examples of pH buffers and equilibrium between different ions and such, but also we can take a step backwards and see how it all comes together big picture. So, for chemistry, there are parts that you do need to sort of memorize, but there are a lot more conceptual side of things. And in fact, if you can master these few conceptual things for each topic, you can pretty much answer most questions. So inquiry-based learning is extremely effective for those concepts, but a lot of people think that for the things that you do have to memorize in chemistry, for example, a definition of Le Chatelier's principle, that sort of stuff you can also use this for. Inquiry-based learning is not only for understanding, but memorization as well. If you understand the importance of something, it becomes relevant to you and it makes it very hard for it not to be that way. So as you probably know, our brains are pretty good at forgetting, but not only that, they're pretty good at changing some stories. So if you might have just memorized something about 3 years ago, after 1 month, you probably remembered it exactly. After 3 months, you probably remembered it exactly. But let's say after 2 years, you might accidentally change some parts of that story and what happened. This happens a lot when you talk about events with friends and one person might remember this happening, but the other friends saw this happen, right? So again, if you can use this for things like Le Chatelier's principle, the definition will eventually come quite naturally to you if you know the importance of each aspect of the definition and why it has to be the way it is. You need to understand what is the importance of each step that you have to do and why would you not do it another way? So for example, when you're dealing with balancing redox reactions, you want to figure out why are you adding hydrogen, why are you adding hydroxide ions to these sort of reactions. And then once again, you can use Kolb's exponential cycle here, which I've mentioned in another video, but I'm not going to mention in this one. So make sure to check that out somewhere on the screen, you know. Okay, so let's talk about the next thing, which is chunking. So chunking is the whole point of breaking one idea into smaller ones. So if you think about this phone number, for example, I could remember all the 10 digits, or I could split it into 3 chunks. I'm sure that you might have done this before when you're trying to remember like your mum or your dad's phone number, but this makes things a lot easier. If we can do this with everything that we're learning in chemistry, that can be just as useful. Now, I think this is extremely important when we come to things like organic chemistry. Like I mentioned, flashcards. Everyone loves to use flashcards for organic chemistry because it seems like it's just things that you have to memorize. There's just so much random stuff that you have to memorize. At a year 12 level, it's actually quite easier than the organic chemistry that you have to do in university, which I've now had to do. And at a university level, the flashcard thing just kind of doesn't work with how much organic stuff there is. So how can you remember things like aldehydes, ketones, carboxylic acids? So for these sort of functional groups, there's a lot that you can do in terms of chunking. For example, you want to think about learning carbonyl and hydroxyl groups. A lot of the main functional groups actually have the carbonyl, and some of them have those hydroxyl, and so you can separate depending on those. So you'll have a few functional groups that exist underneath carbonyl groups, and then you have a few underneath those that have carbonyl and hydroxyl groups, or just those that have hydroxyl, right? It just breaks it down here so that you can just remember like maybe 4 things underneath like hydroxyl groups or stuff like that, instead of just like having to remember like all 20, 30, whatever, you know, there are. Now, what this means is that when you are trying to look at how can you see how these things are related, this sort of level of detail might not be even mentioned in your textbook or even by your teacher, which is why you probably want to extend yourself here and go on Google and look at some more advanced things about organic chemistry for this example. Sometimes actually going outside of the scope of your curriculum to understand stuff that's inside is actually going to save you a lot of time. You just don't want to go too far into the detail of things outside of the scope. So I'll mention that in a bit as well. So, you know, now you got to start to think about how you're going to remember things like hydrogenation or things like hydrolysis of these particular functional groups and what happens to them. How do you make a carboxylic acid, and how do you make an alcohol go to a ketone? These sort of things. Again, you can try to memorize these, but there are like so many things that go around that even if you were to mind map these, it's just going to be like absolutely hectic. If you're really good at mind mapping, you will find a way to be able to do this. And I do recommend that if you have that sort of skill. But one of the things that you can do on the side is learning some of the mechanisms into why is it important that this must happen to the aldehyde here, and why this must happen to the second degree alcohol, and why it goes to a ketone. Why is it that this particular reaction is oxidation? The more that you can ask these why and how questions are going to be very, very useful for you to know that, you know, this second degree alcohol has to become a ketone. A lot of people are going to disagree with me here in saying that going ahead to learn some mechanisms is going to make life easier for you. So this is how I sort of think about some of these things. If there is a reaction that you're finding very hard to remember, then take a look a little bit at the mechanisms, how it works. You don't need to know every little step about how the electrons are moving around and building all these different bonds, but you might look at some things that are sticking out to you. So for example, for a condensation reaction, you're definitely going to notice that there is going to be a H and an OH leaving those two molecules and coming together to create a water molecule. And you want to maybe sometimes do the same to see how oxidation and reduction is occurring in some of the more complex reactions. But it's always another way of approaching this sort of thing. If you get really good at this saves you actually like a lot more time than rote learning this in memorization through flashcards, and it also prepares you to be ready for those sort of curveball questions, which are going to just throw you off if you are using those flashcards. And also with this sort of idea, it makes it easier for you to understand the importance of some sort of reagents and experiments, yada, yada, yada. Okay, so now let's just talk about the whole journey of mastery when coming up to your tests and your exams. And just before I get to that, again, with chemistry, prac reports and that sort of thing, you just gotta think about it again, like why is each statement that I'm making important? Can I make this easier for my teacher to give me marks? Always provide justification, all that sort of stuff. If you want me to talk more about science assignments and prac reports and that sort of thing, make sure to leave me a comment down below and I'll probably do a video on it. Okay, so let's say you're learning something again. Let's go with organic chemistry. So the first thing that I would be doing is pre-study, which I now have a video on that you can take a look at. Once you've pre-studied it, then you're going to go ahead and learn it. So in this process, you're going to be trying to figure out the answers to your questions that we've created with inquiry-based learning. Why is this particular thing important? How does it relate to X? You can represent this through a mind map, which is highly effective for these sort of things where just reactions and a lot of concepts just might seem unrelated, but they actually are. And you need to like sift for those relationships so that you can be prepared for that random curveball question, which is testing you on how two random things might be related. And you might not even see that relationship if you just don't know what to do. And that's usually the reason that people are unable to answer curveball questions, because they can't see exactly what's being tested in that question so that they can be reminded, oh, I just need to talk about this. Just remember that the curveball questions are the ones that differentiate who's at the very, very, very top versus those who are just maybe at the top or lower. After you got that mind mapping down, you want to have a sort of schedule to make sure that you are still incorporating some spaced repetition with your mind map or whatever else that you are doing. Usually the general rule is that if you have strong study techniques, you can do it 1 day, 1 week, and then 1 month apart. So this usually works just because the study techniques that you have are just so strong that looking at it 1 day, 1 week, 1 month apart is never going to be after your forgetting curve because of these strong techniques. And throughout, you're going to be doing some practice questions that you specifically want to focus on the ones that are going to be tackling your biggest weakness at that point. There's no point doing all the practice questions. And then when we start to get closer to your test or your exam, you want to consider those practice exam papers. The big thing again is that you want to figure out all of your weaknesses to do with the concepts in practice questions before practice papers. Practice papers are not the opportunity to figure out where your weaknesses are, because that is the best opportunity for you to have a simulation of what it would be like to sit the test or exam on that day. This is your best opportunity to figure where your issues are with time, focus, and concentration. These exam-specific issues. Now, a thing that is like extremely beneficial is that if you are at the point where you're getting close to just having to fix up a few little things and being prepared for those very difficult curveball questions, the thing that you can do is create questions for yourself. There is a lot of research on this, so if you want to search up this thing called Bloom's taxonomy, you can check that out. But this is the stage where you are almost at mastery of the content. Think about how you might learn a second language. You're going to be able to memorize all the words. You're going to understand someone talking to them. But to be able to create stories or create conversations and use words from your vocabulary to talk to someone, you need a lot of like understanding to reach that point. So the same thing sort of happens with anything that has tests and exams. If you are able to create questions for yourself and think in the mindset of an examiner, you're going to be able to target your most specific weakness, quite similarly to the way that you did inquiry-based learning. But remember that inquiry-based learning is learning. Now you're into the revision stage. You can still be asking inquiry-based learnings to build an even deeper understanding. But when we're in this create stage, what we're really doing is creating the hardest of the hardest curveballs that we might see. And if we can be prepared for those, which we know are tackling our biggest weakness at this point, we should be more prepared for that next exam. The research shows that in just creating the question itself, there is so much learning that can be had there in thinking like that examiner. You don't necessarily have to have the answer to that question. In just creating the question and attempting it, that is most often more than enough of learning that you can take out of it. And then you can fix up a few little things here again with Kolb's exponential cycle, and then you'll be set for your exam. Hope you enjoyed. Let me know what subject you want to see next, and I'll see you guys in the next one. Bye-bye.